Assalamu alaikum, sir. The name of my project is Earthquake Resistant Infrastructures. So here in the name, the concept about or the idea about our project already came to your mind. So it is an earthquake related project, and due to earthquake almost 60,000 people die every year. And when I came to research about it, there came mainly two procedures by which these kinds of deaths can be prevented every year. So the first procedure is dune mass dampening. When you understand about the dune mass dampening, the dune mass dampener is also known as a harmonic absorber or seismic dampener, which is a device molded in the structures to reduce the amplitude of the mechanical waves coming from the earthquake. In this case, we use it in high infrastructures, hanging it to the roof of that infrastructure to stabilize the building's vibration during the earthquake period. So now let's show you the physical demonstration about how the procedure works. Before and after placing the weight or the dampener on it. So after seeing these two, you can easily say the differences between after and again having the tuning devices fixed. It mainly occurs due to the momentum of the heavy mass fixed like a pendulum within the above heights of the infrastructure. When the quake occurs, the center of the gravity of the infrastructure along with the equilibrium of it moves in one direction, for which the shaking of the above structure occurs. But when we use a dampener over it, a tuning dampener over it, or which is a pendulum here, over it, we can see that it moves to the other direction due to its momentum, for which the equilibrium is balanced again, and which gives the dwellers of the building time enough to move to a safe direction, of which we can save a lot of lives. And now you have been also thinking about what should be the height of this thing. So in this case, you have to keep in mind that it should be about 1/6. The height of the thing, or the placement of the thing should be about 1/6 of the total building height. So, and for your kind information, we can also say that it's also in procedure in the building or the highest building of Tenang in 101 of the country Taiwan. On the other hand, it's also used in Canada, Australia, and many other different countries for its dampening procedure. And about the height, if we come to it again, if it is too low, then we will see that it's moving too much. On the other hand, if it's too high, then the procedure will be blocked again. So it should be fixed according to the procedure, about 1/6 of the height of the total building. The next procedure is the base isolation process. In this process, we are using the straddling pendulum technology. So in this technology, there is a swing beam. Which is prepared like this. You can see the structure. It is actually made up of three parts. The first part is the wall base that I placed here. Then the second part is the the string plates, which move freely over it. And the third part is the walled infrastructure above it to keep it contact. So when I move it, you can see the movement inside it. So you can see the movement inside it, but the above remains isolated. So you can see the movement in this video. You can see this process as only one directional, but the earthquakes will not be in one directional all the time. So in this for this process, there will be three more plates, three more devices like this set over and over again to the three directions that it could come. So, you can watch the procedure how it will be fixed in this. Not only this, as the infrastructure is of great variety and it's a huge load of mass, then we need at least 4 of these things to be fixed together to isolate the whole building process, to support the whole structure. They form the base, they in totally form the base isolation process, which you can see in this video. It has the purpose of absorbing the seismic waves energy and isolate to reduce the initial shake of the horizontal ground in the pendulum. In this way,